So in vector algebra, first we try to understand what are the vector quantities and scalar quantities. So vector quantities you must be knowing, I think, those physical quantities which have both magnitude as well as direction. Okay?
Yes, sir.
Physical quantities having both magnitude as well as direction. Example is force, acceleration, displacement, etc. And scalar quantities which have magnitude only. Scalar quantities a physical quantity a physical quantity. Let it be physical quantities.
Okay.
So a physical quantity or physical quantities having magnitude only. For example, time period, work, angle, temperature, etc. So these are scalar quantities. We cannot say that 30 degrees Celsius in north direction because
Yes,
it
sir.
does not require any direction. We cannot say work is being done in north direction or south direction.
Yes, sir.
Work has no direction. So these are scalar quantities. So how do we denote a vector? If we write AB vector, this arrow shows that this we are representing AB as vector
Okay.
directed from A to B.
Yes.
Directed from A to B. Okay. So what is the direction of vector? From A to B. Okay. And we know that every measurement is taken from the origin. Okay. So if we want to write AB vector, it is as simple as that OB vector minus OA vector. What is OB vector? It can be written as position vector of B, position vector of B minus position vector of A.
A.
Now, what is position vector? It is nothing. It is the location address. It is the coordinates.
Is the point at which
Cartesian
the
system, we use coordinate. If we say coordinate is x coordinate is 2, coordinate is 3, then on x-axis, the distance from the origin is 2 units, and on a y-axis, distance from origin is 3 units. Similarly, in vector, we say AB vector is OB minus OA. That means position vector of B. Position vector means the coordinate itself,
position?
the location, the address, okay,
Yes, sir.
minus position vector of A.
A.
So suppose we have this way. This is A and this is B. Okay, and this is the origin. This is origin. As we know that every position or location is taken from origin.
Origin.
Okay, so
Yes, sir.
if we want to find AB vector, then it will be OB vector minus OA vector.
OA vector.
Okay, suppose we have position vector of A, suppose 1, 2, 3, and position vector of B is 4, minus 2, 3, or 4. Okay, so
Okay.
what we do, AB vector will be OB vector minus OA vector. OB vector is nothing, that is 4i cap minus 2j cap plus 4k cap. 4i cap minus 2j cap and plus 4k cap. What are these I cap, j cap, k cap? These are nothing, but it tells about the direction.
Okay.
I cap along x-axis, j cap means along y-axis, and k cap along z-axis, g-axis. Okay.
Yes, sir.
So as in Cartesian coordinate, if we take a point P, x comma y, okay, or 2 comma 3, 2 says that it has distance on x-axis from origin is 2, and distance on y-axis from origin is 3. And the same thing in vector, I cap means distance on y-axis, x-axis, along x-axis, and j cap along y-axis,
Along y-axis.
k cap along y-axis.
Z-axis, right, sir? K cap is Z-axis.
Yes, z-axis. So minus OA will be I cap plus 2j cap minus plus 3k cap.
Yes, sir.
So this will be 4 minus 1, 3i cap minus 2 minus 4j cap, and 4 minus 3 k cap.
K cap.
So this will be AB vector.
Okay.
To make you remember how to find a vector, if the position vectors are given or the coordinates are given, as simple as that, if we need to find AB vector, then remember B minus A.
Yes, sir.
B minus A.
A.
So simply, if we have suppose PQ vector, we need to find PQ vector. Position vector of P is suppose 2, 1, minus 3, and position vector of Q is suppose minus 3, 2, 1. Okay. So PQ vector is nothing but Q minus P. That is minus 3 minus 2 minus 5 I cap plus j cap plus 4k cap. Okay,
Yes, sir.
that's it. This will be PQ vector. Now, co-initial vector. Co-initial vector. Vectors. If two vectors have same initial point, if two vectors have same initial point, suppose we have vector A and vector B, both have same initial point, O, then these two vectors are said to be co-initial vectors. Null or zero vector. The vector which has magnitude 0. Now we will talk about the magnitude of a vector. Zero vector is representing like this. So magnitude is 0. Magnitude equals to 0. Now magnitude of a vector. We will talk about magnitude of a vector. Magnitude of a vector. I'm trying to give you the concept with the simplest approach that you can understand. Right? Try to. So just after the class, you take a break and then revise all the things that I teach you. Right?
Yes,
Magnitude of a vector.
magnitude of a vector.
Suppose we have a vector A equals to xi cap plus yj cap. What is this cap?
It shows that it's a vector.
I have to ask the question myself and answer.
No, I thought so. It shows that it's a vector.
Yes, it's a vector, but what is the difference between this A vector or A cap?
Cap is like the position, and then vector would be like the whole.
Cap, A cap is, it shows that unit vector.
Okay.
Yes. Xi cap plus yj cap plus zk cap. So magnitude of A will be x square plus y square plus z square and square root of it. Remember this. Magnitude of A, x square plus y square plus z square under root. Yes. And suppose, let's take an example. Suppose we have A vector equals to I cap plus j cap plus 2k cap. So magnitude of A will be, let's take minus over here.
Okay. So 1 minus 1 plus.
Idea. No, minus actually doesn't affect the result. That's why I have taken minus.
Okay.
1 square plus minus 1 square plus 2 square. So it becomes 1 plus 1 plus 4. That is square root of 6. So this is the magnitude of vector A. Now unit vector. Now coming to unit vector. Unit vector is what? What is unit vector? Unit vector which is having magnitude 1. A vector whose magnitude is 1. That is called unit vector. So it is denoted as A cap. Suppose we have a vector A. How to find a unit vector from a given vector? Or in other words, how to make a unit vector from a given vector?
Okay.
Means if a vector is given, suppose we have a vector given as, let's say, I cap plus 2j cap plus 3k cap. Okay?
Yes.
And we have to find the unit vector. So what we will do, first we will find magnitude. Magnitude will be 1 square plus 2 square plus 3 square. That comes to 4 plus 1, 5 plus 9, root 14. Okay. Now, if we have to find unit vector A cap, that is vector A divided by its magnitude. Okay. So
Okay.
unit vector is the vector divided by its magnitude. So that will be I cap plus 2j cap plus 3k cap divided by square root of 14. And so it will be 1 over root 14 I cap plus 2 over root 14 j cap plus 3 over root 14 k cap. Now, if you find the magnitude of this vector, you will find that its magnitude is 1. Why? Because it will 1 over root 14 is common. Okay.
Yes,
And
sir.
1 square plus 2 square plus 3 square is again root 14.
Root 14.
So they will be cancelled out and you will get 1. So this is the formula for what?
So why is a cap there, sir, when for unit vector?
To denote unit vector.
So unit vector is also under cap.
See, yes. How will you distinguish between a unit vector and a vector?
Yes, sir.
So there is symbol for that. A cap means it's a unit vector, and if just an arrow, that means it's a proper vector.
Okay.
Okay, and this is the formula for finding unit vector. Now, one more thing that is important: magnitude of A square. I am writing over here. Magnitude of A square is A dot A. What is dot product? We will study after some time. Okay. But since we were talking about magnitude, so there is a property. Magnitude of A square is A dot A. This dot product is square product. We will be studying later on in today's class only.
Okay.
Now coming to algebra of vectors. Algebra of vectors. First, addition and subtraction. Suppose we have two vectors. Let we have two vectors. Vector A equals to A1 I cap plus B1 j cap plus C1 k cap. And vector B is A2 I cap plus B2 j cap plus C2 k cap. Then we have A plus B vector equals to A1 plus A2 I cap plus B1 plus B2 j cap plus C1 plus C2 k cap. As simple as that. Means we add the coefficient of I cap, we add the coefficient of j cap, and we add the coefficient of k cap separately. Okay?
Yes, sir.
Vector A minus vector B. This will be A1 minus A2, B1 minus B2 j cap, and C1 minus C2 k cap. Okay.
Yes, sir.
So let's take an example. Suppose we have a vector equals to minus I cap plus 3j cap minus 5k cap. And B vector is 2I cap plus 1j cap plus 2k cap, 3k cap. Find vector A plus vector B and vector A minus vector B. Yes, you tell me, David.
So we'll
You
do
tell me what will be the
minus 1.
value of A plus B vector and A minus B vector.
Minus 1 plus 2 I cap.
Yes, A plus B will be minus 1 plus 2, that is 1I. Okay.
And
And 3 plus 1.
4j
Yes.
cap
Yes.
plus 2k cap.
Minus 2k cap.
Minus
Minus 5
2k.
plus 3 minus 2.
Minus 2k cap.
And what is A minus B vector?
You'll get minus 3i
Minus 3I cap
cap plus minus 2 j cap
plus 2j cap. Yes.
plus 2j cap, and then
Minus 8
minus 8 j cap.
cap. Yes. So this is the answer.
Yes, sir.
One more thing, parallel or collinear vector. Collinear vectors.
Okay, sir.
Two vectors are parallel, said to be parallel vectors. Let A and B are two vectors.
Yes, sir.
A vector is parallel to B if A can be written as in terms of where lambda is a constant. Suppose we have vector A equals to 2I cap minus 3j cap plus 4k cap, and B vector is minus I cap and plus 3 by 2j cap plus minus 2k cap.
Okay.
So see, vector B can be A can be written as minus 2 times B vector.
B vector.
Minus 2 times B vector. Let's see whether we get it or not. If we take minus I plus 3 over 2j cap minus 2k cap, what we get? We get minus plus 2I cap and 2 will be cancelled, minus 3j cap and plus 4k cap.
Plus 4k cap.
Isn't it? So
Yes,
A vector can be written as minus 2 times B vector. Means it is
they are parallel, sir.
lambda B vector. So it is parallel. They are parallel. A vector is parallel to B. Now, it seems to be little bit difficult
Yes.
whether a vector can be written in terms of the second vector. One vector can be written in terms of second vector or not.
Hmm.
So you will have to do some work for that. I'm giving you a simple tip, simple technique, so that you can easily find whether these two vectors are parallel or not.
Yes, sir.
That is, take the coefficient, take the ratios of the coefficient. Okay. Take
Okay.
take the ratios of the coefficient of I cap, j cap, and k cap. So 2 over -1, and this is equals to -3 over 3 over 2. Okay.
Hmm.
And this is equals to 4 over -2. You can check it. Means if you see, if you find that the ratios are equal, this becomes -2, and this will also become, this 2 will go in the numerator, -2, and this is also -2.
Okay, yes, sir.
So if the ratios are equal, then simply we can say A is parallel to B
Oh, okay.
or collinear to B.
Got it. But after you do this, you don't have to prove it again, sir, or do you have to prove it?
No, no, you don't have to prove.
Okay.
Or if you want to elaborate it, you can just write that A is -2 times B,
Okay.
because you got -2, ratio is -2.
Yeah.
Okay. So basically you had taken A, B equals to -2,
Yes, sir.
right?
Yep.
So A equals to -2 times B.
Correct. Okay. Yes. Yes, sir. Got it.
Now we will be studying scalar or dot product.
Scalar or dot product.
The name suggests the product of two vectors will be a scalar quantity. The name suggests it will be a scalar quantity.
Yes, sir.
Scalar or dot product. Suppose we have two vectors. Vector A equals to A1 I cap plus B1 j cap plus C1 k cap. And vector B is A2 I cap plus B2 j cap plus C2 k cap.
Okay.
So we have A dot B equals to A1 A2 plus B1 B2 plus C1 C2. As simple as that.
Okay.
How does it happen? How does it happen?
They just multiply.
Just make you understand. I just make you. If you multiply them, then A1 A2 I dot I. Okay.
Yes, sir.
B1 B2 plus B1 B2 J dot J plus C1 C2 K dot K. But at the same time, you will have A1 B2 I dot J, A2 B1 I dot J, and A2 C1 and A1 C2 as well, I dot K and K dot I. But all those terms becomes 0.
Okay.
Getting me? Why? Because there is property that I dot I, J dot J, K dot K equals to 1, but I dot J, J dot K, and K dot I, these all are 0. That's why
Okay.
That's why we simply get A1, A2 plus B1, B2 plus C1, C2.
Got it.
Okay.
Yes, sir.
So if we have to find the dot product or scalar product, the name suggests you will get a constant because A1, A2, B1, B2, C1, C2, A1, B1, C1, A2, B2, C2 are what? Constants. So dot product will be a constant. Sum
Yes.
of all this will be a constant. And here we have angle between two vectors. Angle between two vectors.
So can you say that again?
Angle between two vectors.
Okay.
Cos theta, theta is the angle between two vectors. Let theta be the angle between two vectors. Okay. So cos theta is A dot B, dot product of two vectors, divided by its magnitude. Okay.
The magnitudes are multiplied, sir.
Yes, magnitude will be multiplied. Magnitudes are constants.
Yeah.
They can simply be multiplied. And we can also write A dot B we can write this way as well. A dot B equals to A. David, however, we have already done an example of it. Oh, that is the problem.
The caps got moved around, sir.
Yes, yes. In the direction of vector A equals to I plus J plus 2K.
Yes, sir.
Vector A I plus 2J plus 3K.
Yes, sir. Wait, not 2J,
I
sir.
plus
This
J plus
is
2K.
I plus J plus 2K, not.
Okay. Oh. So unit vector A cap can be determined by dividing by the magnitude of that vector. So first we need to find the magnitude. Magnitude is 1 square, 1 square, 2 square. So that becomes root over 6. So A cap will be 1
Root over
over root 6 I cap,
Yes, sir.
1 over root 6 j cap,
J cap.
2 over root 6 k cap. So this will be the unit vector in the direction of given vector A.
We don't have to solve it, sir.
No,
No, okay.
what the
Now just
complete
stick to the
thing?
whiteboard, right, sir?
Yes. For given vectors, two I cap, just a minute, just a minute. Again, it will destroy all these things, all this work.
Yes, sir.
That is the issue. Vector A A vector equals to
2 I cap minus.
2 I cap,
Yes, sir.
2 I cap, yes,
Minus J cap plus 2K cap
minus J cap plus
2K
2
cap.
K cap.
And B
And B vector is what?
minus I cap plus J cap minus K cap.
Okay.
Find the unit vector of the direction of the vector.
In the direction of A plus B, right?
Yes, sir.
The vector A plus B. For given vectors A and B, find the unit vector in the direction of the vectors A plus B. So first you will find A plus B, that is 2 minus 1, 1 I cap, okay? And J plus J, 1 minus J plus J is 0J. And 2K minus 1K is 1K. So basically you have I plus K.
Yes, sir.
Now magnitude of A plus B will be 1 square plus 1 square, that is root 2. So unit vector in the direction of A plus B
Divided by magnitude.
will be 1 over root 2 I cap plus 1 over root 2 J cap.
J cap.
Yes.
K cap.
1 over root 2 K cap. Question number 10.
Find the vector in the direction of. Find the vector in the direction of the vector.
8 units, right?
Yes, sir. I cap minus J cap is 2K cap.
Okay. It's 5I minus J plus 2K.
Yes, sir.
Which has magnitude 8 units. So let A vector equals to 5i cap minus j cap plus 2k cap. So get the magnitude of it. That will be 5 square plus minus 1 square plus 2 square, and this will be square root of 30. Is it?
Yes, sir.
So A cap will be vector A over magnitude A.
So 5
So this will be 5
under
over
30
root
I.
30 I cap minus 1 over root 30 j cap plus 2 over root 30 k cap. This is unit vector. Okay?
Yes, sir.
Means its magnitude is 1. If you multiply by 8, then its magnitude will become
8.
what?
Magnitude
8.
become 8.
Yes. So vector whose magnitude is 8 will be
8 into A cap.
it will be 8 a cap. Okay. So this will be 40 over root 30 I cap minus 8 over root 30 j cap plus 16 over root 30 k cap.
Yes, sir.
This will be the answer. Got it?
Yes, sir.
So that the given vectors are collinear. So just take the ratio of the coefficients. 2 over minus 4 is negative 1 over 2, negative 1 over 2, and negative 1 over 2. So they are collinear. Can you do yourself?
Can you say that again, sir?
Take the ratio of the coefficient of I, j, k. If they
Okay.
are same, then they are collinear. That's
Okay.
it.
Okay, I'll try, sir.
You will be doing at home. Okay.
Okay.
Now find the direction cosine of the vectors. What is this direction cosine?
Is it the angle?
Just a minute. Let me copy the question. And the direction cosines of the vector vector I plus 2j plus 3k. I cap 2j cap plus 3k cap. So direction cosine is what? Cosine of angle made by a vector with positive x-axis, y-axis, and z-axis. Okay.
Okay.
So let vector A is I cap plus 2j cap plus 3k cap. So get the magnitude of it. That becomes root over 14.
Yes, sir.
So direction cosine is nothing but the coefficient of I, j, k of a unit vector. Okay.
Okay.
2 over 14 j cap plus 3 over root 14 k cap. So direction cosines are 1 over root 14, 2 over root 14, and 3 over root 14. That's it. Got it?
Yes, sir. Okay, so that is basically it. So can you show the 10th question once again, please?
We did 10th question.
Yes, sir. Can I once see it?
Okay.
Okay. Okay. Thank you, sir.
Here we had to find the magnitude, find a vector in the given direction, and magnitude should be 8. So we just found out, we just determined the unit vector, and then we multiplied by 8.
8. Yep, sir. Got it, sir.
Find the direction cosine of the vector joining the points A, B. Direction cosine of the vectors joining the points A, B.
Directed from A to B. What does directed from A to B mean, sir?
AB vector. I already made you
just the AB
understand.
vector. Okay.
Yes. Direction is from A to B. A is initial point.
So it's
B
an AB
is
vector.
terminal point.
Got it.
Find the direction cosine of the vector joining the points A, B. So first you find AB vector.
Then
That will be -1 I cap plus -2 j cap plus 1 -3 k cap. So this will be -2 I cap
minus
-4 j cap and plus 4 k cap.
Yep.
Now get the magnitude of this vector.
So minus
Magnitude of AB vector equals to
4 plus
-2 square minus 4 square, 4 square. So this is 4 plus 16 plus 16.
16.
Square root of 36 is 6.
Yep.
So AB cap equals to AB vector divided by magnitude of AB vector. So this will be -2/6 -2/6 I cap -4/6 j cap 4/6 k cap. So this is -1/3 I cap -2/3 j cap plus 2/3 k cap.
K cap.
So direction cosine will be
-1/3.
-1/3 -2/3 and 2/3. These are direction cosines.
Yes, sir.
So that the vector I plus j cap plus k cap is equally inclined to the axis OX, OY, OZ. Equally inclined means their direction cosine should be equal. This is must be equal if the vector is equally inclined. Equally inclined with axis. DCs are
Equal.
1 over root 3, 1 over root 3, 1 over root 3. Is it?
Because one. Oh yes, 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 sir.
Therefore, cos alpha, cos beta, cos gamma. Cosine of angles with x-axis, y-axis and z-axis. This is called direction cosine. Okay?
Okay.
Since these are equal, so cos alpha, cos beta, cos gamma are equal. That means alpha, beta, gamma are equal.
Okay. Alpha, beta, gamma are equal. Cos.
Question number 15. Find the position vector of a point R which divide the line joining 2 points P and Q, whose position vector are given in the ratio 2:1 internally and externally.
Okay. Point of divide line. So how will it do externally when it's saying that it's divides the line joining the P and Q points?
Already discussed. Once again, we are going to discuss, so do not to be worried at all.
Okay. No, sir, I remember what you said. Like, but
Yes, yes. MB vector minus NA vector over M minus N. This one.
yes, sir.
Right
So,
corner.
like, they already gave us 2 points, and then they're saying it'll P will come
Yes.
devise the line joining. So that means externally it should come outside and divide the line, right, sir?
We have to do both the things, na?
Yes, sir.
Externally and internally both. Vectors are 2 points PQ with position vectors are I plus 2j minus k. I plus 2j minus k.
Hmm.
And minus I plus j plus k. In the ratio 2:1.
Yes, sir.
Respectively in the ratio 2:1.
So,
Internally as well as externally. So we have PQ and position vectors are already given 1, 2, minus 1 and position vector of Q is given as minus 1, 1, 1.
1. Yes, sir.
And we have to find the position vector of R.
They gave this, the ratio is 1:2.
2:1.
2:1.
Yes. So we have Position vector of R will be what? 2 times minus 1 and 1 times 2b plus 1a. Okay. So 2 times minus 1 minus 1. So minus 2 minus 1 is minus 3. And 2 times 1 plus 1 times 2. So 4
Yes.
and 2 times 1, 2 and 1 times minus 1. So this is 1. So position vector of R is minus 3i cap, 4j cap
J cap plus 1k
plus
cap.
1k cap. Okay. This is internal section, first
Yeah.
part. And external section, we have OR का position vector is 2 times Q vector, okay,
Yep.
and minus 1 times
P vector.
P divided by 2 minus 1.
Yep.
So this will be 2 times minus 1, that is minus 2 minus 1, minus 3i cap. Oh, no, minus 2 minus 1. And here minus 2
So how will it be minus?
plus 1. Yes, we mistaken over here. Minus 2 plus 1, that is minus 1. Minus 1 I.
Wait, I'll just write it down, sir.
Yes. And 2 times 1 plus 2, 4. 2 times 1 minus 1, 1. Yes. This time 2 times minus 1 and minus 1 is minus 3i cap. 2 and minus 2, 0j cap. 2 plus 1, 3k cap. So minus 3i cap plus 3k cap.
Okay.
Got it,
Got it, sir.
David? Okay. Question number 16 is you need to find the midpoint. So midpoint of PQ will be 2 plus 4 over 2, 3 plus 1 over 2, and 4 minus 2 over 2. That's it.
Oh, so just divide it or
Yes.
okay.
Question number 17. So that are the points A, B, C with position vector A. Just a minute. Question number 15. Okay.
Okay. We did 15 just now, right, sir?
We did, yes,
We're
question
doing-
number 17. Na?
Yes,
17.
sir.
Yes.
17.
So that is the points A, B, C Which position vector? A position vector of A is position vector of A is A equals to 3i cap minus 4j cap minus 4k cap, and B is 2i cap minus j cap plus k cap, and C is I cap minus 3j cap minus 5k cap. So these are the position vector.
Yes.
This is position vector of A, this is position vector of B, and this is position vector of C.
C.
So first you need to find AB vector, that is B minus A, BC vector, C minus B, and AC vector, C minus A. AB vector will be 2 minus 3 minus 1 I cap plus 3j cap and 1 plus 4 5k cap. And BC vector will be 1 minus 2 minus I cap minus 3 plus 1 minus 2j cap and minus 5 minus 1 6k cap. C minus A 1 minus 3 minus 2I cap plus j cap minus k cap. Okay. Now take the dot product of any two AB dot BC will be what? Minus 1 into minus 1, 3 into minus 2, plus 5 into minus 6.
I don't think it's minus 2. I think it's plus 2 for the BC.
BC, C minus B, minus 3 plus 1, that is minus 2.
Okay.
It is not equal to 0.
No.
BC dot CA, AC, BC dot AC. So minus 1, minus 2, minus 2, 1, minus 6, minus 1. So 2 minus 2 plus 6 does not equal to 0.
No, sir.
AB dot AC minus 1, minus 2, plus 3, 1, and plus 5, minus 1. So this is 2 plus 3 minus 5 is 0.
0.
Therefore, AB is perpendicular to AC and angle A is right angle. Therefore, ABC form a right angle triangle. Therefore,
this is of a right angle.
Triangle ABC is a right angle triangle.
Yeah.
Okay. Now, question number 18 and 19 we will discuss. Then we will end today's session. And you need to go through all these things. Still, homework is pending. So,
yes,
make sure you send your homework by today evening.
Yes. 1 minute, sir. Just.
Question number 18. AB plus BC plus CA equals to 0. Which of the following is not true? Okay, which of the following is not true? See, if we take any closed figure like triangle ABC, and if we take direction in cyclic order AB, BC, CA, then it is always AB plus BC plus CA equals to 0. Okay? In cyclic order. So I think only D part is not correct. Okay? Okay, no, D part is also correct. D part is also correct. AB plus BC minus AC, CA will be there. I think B and C both have the same option. C will be the answer. There is some error in the choices. Okay.
Okay.
Question number 19. A and B are two collinear vectors. Then which of the following are incorrect? Collinear vector. The respective components of A and B are not proportional. This is not correct. Incorrect. C.
The collinear means they both are parallel to each other, so there will be.
Collinear vectors, the respective components are in proportion.
Yes, sir.
But you need to find incorrect, not correct.
So C will be incorrect, right, sir?
Yes. Okay. So we will end today's session. And
Okay,
I
sir, can you
expect
show me the 17th question again once, please? Okay. Got it, sir.
okay. So your homework is the whole thing. Okay.
Yes.
Please send your homework and do your work properly. Go through all the questions once again.
Understood, sir.
Right. And in the tomorrow's class, cross product will be done. Most probably, this chapter will be completed. Vector part will be completed tomorrow. Okay, so you need to submit all of your work.
Yes, sir.
Take care. Bye.
Thank you, sir. Take care. Thank you. Bye bye.